What if your doctor could test a new heart medication on a perfect copy of your heart without you ever having to take a single pill? Or what if a surgeon could practice a really complex procedure on you dozens of times before ever making the first cut? I know, it sounds like something straight out of science fiction, right? But it's actually the future of medicine. Today, we're diving into the incredible, revolutionary concept of the human digital twin.
So, here's how we're going to break it all down. First, we'll look at the big one-size-fits-all problem medicine has right now. Then we'll introduce the digital twin, see how these virtual versions of us are actually built, and check out some of the mind-blowing ways they're being used. Of course, we'll also have to talk about the challenges we need to solve before we wrap up by imagining what your own healthcare might look like in 2030.
Okay, so to really get why digital twins are such a game changer, we first need to talk about a huge fundamental limitation in the way medicine has worked for a long time.
For decades, pretty much every new drug, every new treatment has been developed for the so-called average person, based on data from huge clinical trials. But here's the catch. There is no such thing as an average person. We're all different, so a treatment that works wonders for that statistical average might be totally ineffective for you, or worse, even harmful, all because your biology is one of a kind.
And this is the exact problem the human digital twin is built to solve. And believe it or not, the idea for it comes from a place you probably wouldn't expect.
Yeah, the very first digital twins weren't made for people at all. They were made for spacecraft. NASA was actually the pioneer here. They created these amazing virtual replicas of their rockets and satellites so they could run simulations, predict when a part might fail, and solve problems from millions of miles away. Now we're taking that exact same concept and applying it to the most complex system we know of, the human body.
So what is it exactly? Well, at its core, a human digital twin is a virtual model of a person. But, and this is the most important part, it's not just a static model. It's a living, breathing simulation that is constantly being updated with real-time data from its physical counterpart, you.
This quote really just nails it. The key words here are dynamic, it changes as you change, and unique physiology. This isn't some generic model of a human. It's a virtual replica of you, and only you.
And let's be super clear, we are not talking about some fancy 3D anatomy chart you'd see in a classroom. A human digital twin is what's called a multi-scale simulation. That means it models everything from how molecules are bumping into each other inside your cells, to how those cells form tissues, all the way up to how your heart, lungs, and entire organ systems are working together. It is a truly holistic digital version of you.
So the next logical question is, how on earth do you build something so incredibly complex? Well, the answer is data, a massive data bridge that connects your physical body to your virtual twin. Let's see how that gets built.
It all comes down to combining three main streams of information. First up is omics data. That's things like your genetics. Think of it as the deep-down biological blueprint that tells the model about your natural predispositions. Then you've got real-time data from biosensors and wearables, like your smartwatch, which gives it a constant stream of what's happening right now. And finally, medical imaging, like MRIs and CT scans, provide the structural framework, while your medical records add all the important historical context.
Then, incredibly powerful algorithms just churn through this mountain of data, looking for these tiny, subtle patterns called digital biomarkers. These are the digital smoke signals. For example, a tiny, almost unnoticeable change in your walking pattern picked up by your phone could be a super early warning sign of a neurological issue. We're talking about predicting major health problems months, maybe even years before you'd ever feel a single symptom.
This predictive power is just amazing. But where the human digital twin really starts to feel like magic is when it's used as a digital proving ground, letting doctors test out high-risk procedures in a totally safe virtual space.
Think about it. A surgeon planning a complex heart operation can now basically perform that surgery on your digital twin over and over again, testing different approaches to see how your unique blood flow would react. Or in cancer treatment, doctors can throw different chemotherapy cocktails at a virtual tumor to find the absolute best combination, the one that's toughest on the cancer but easiest on the patient, all before a single drop of medicine enters the body.
And this idea scales up in a massive way. Imagine testing a new drug not just on one digital twin, but on an entire population of thousands of virtual patients. These are called in silico trials, and they could completely revolutionize how we develop new medicines, making the whole process way faster, a lot cheaper, and much safer. Okay, so as amazing as all this sounds, we have to be realistic. The road to this future isn't exactly smooth. There are some really significant hurdles we need to clear, both on the technical side and on the ethical side.
First, there's the technical challenge, which is just sheer power. I mean, trying to simulate the unbelievable complexity of the human body in real time requires a mind-boggling amount of computational horsepower. We're talking more than most supercomputers have today. And just as critical is model fidelity, making sure the math is right, because the digital twin is only as good as its code. A tiny flaw in the model could lead to a dangerously wrong prediction.
And then there's the arguably trickier hurdle, governance. Who owns the data that makes up your virtual self? How do we keep something so personal completely secure? We've got to navigate complex privacy laws, prevent anyone from misusing this information, and answer some really profound ethical questions that pop up when we can literally simulate a person's entire body and health. But if we can overcome these hurdles, what does this future actually feel like for you and me? Well, it promises a totally new, proactive relationship with our own health. Just picture this for a second. You go for your yearly physical, but instead of just the usual checkup, it's more like a software update for your digital twin. That twin lives securely up in the cloud, constantly running simulations, monitoring your health, and flagging tiny changes that need attention long before they could ever become serious problems. You see, this isn't just about a new tool or a new gadget. It is a fundamental reinvention of medicine. The researchers and scientists building these models today are more than just scientists. They are becoming the digital architects of a completely new kind of healthcare, one that's genuinely predictive, truly personalized, and deeply preventative.
In the end, what the human digital twin gives us is a map of human health that's more detailed, more dynamic, and more personal than anything we have ever had before. It's a whole new frontier for medicine. And maybe the biggest, most exciting question it leaves us with is this. With this incredible new map in our hands, what will we discover?